Hi, good afternoon, and welcome to the Environmental and Natural Resource Technology, or the Earth Center's webinar on bridging skills gaps through desktop simulations. The Earth Center is a National Science Foundation Advanced Technological Education National Center. We are housed out of Central Carolina Community College in North Carolina. And our scope is nationwide. We provide a wide range of resources for faculty and students across the country as they relate to environmental and natural resource technology programs. These include resources for classroom use, professional development, mentoring, and a number of other services that you can find out about by visiting our website at earthcntr.org. We represent quite a few of these 500 environmental technology programs throughout the United States. So if you are one of those faculty members in one of those programs, please reach out. Just to show you a little bit about our scope, I am the principal investigator for the Earth Center, and I am based out of North Carolina, but we do have sub-award partners throughout the country. Today's presentation is going to be one of the projects that we've worked on with our partner, the National Partnership for Environmental Technology Education, or National PEAT, based out of Maine, and led by Kirk Laughlin. And I'm going to pass that over to Kirk.
Okay, thank you. Again, as Andy said, my name is Kirk Laughlin. I'm the Executive Director of the National Partnership for Environmental Technology Education. We're a national leader in environmental health and safety technician education. We like to tout ourselves as capacity building for community colleges, business, industry, and government. We have a network with 400 plus community, technical, and tribal colleges throughout the U.S. and the U.S. territories. Through what we call our Community College Consortium for Health and Safety Training that supports 125 plus training organizations across 30 states, reaching over 50,000 workers and students annually. As I mentioned, we are capacity building organization. Our whole concept is that we'll provide training to faculty members at community, technical, and environmental training centers to give you the capacity then to go out and train in your local area. That's how we achieve the larger numbers. We are heavily governmentally funded. Our primary funding source for this particular part of the program is the National Institute of Environmental Health Sciences, which is under the NIH umbrella. And I must apologize, I'm battling a cold and sore throat, so I'll see how we do going through all this. But anyways, one of the things that we do with our program is similar to the Earth is we support the faculty members when they come to our training programs in the respect of travel, per diem, overnight accommodations, etc. And once you've come to our the trainer programs, you then go back with curriculum and other supporting materials back so that you can use it in your organization. This is a great partnership between National PEAT and the Earth Center in the respect that we end up being one of the source areas of training and curriculum development based on an online program we developed several years ago. What we found was when we started with our annual greatest training for environmental health and safety and hazardous waste, is a lot of the folks coming in had a varied background. So our master trainers would end up taking extra time to try to bring some of the folks up to speed. This online program allows folks to come up to speed in that respect, and also give more flexibility for faculty members who are building this program into their curriculum that they have for HAZWOPER. The program has 17 modules. It's intense, but it's a self-paced program that goes through. And it can be a standalone program, or what we'll be talking about, or others will be talking about during today's presentation, is how you can use this with the AVR components that Earth Center has graciously agreed to assist us in developing. So, with that, I think I will turn it over to Lindsay Holmes, who is one of our master trainers and has been working very closely with the rest of the Earth team and developing, and they'll be debuting the work that they've been doing to help this program out. Thank you.
Yeah, Lindsay, before I actually hand it over to you, I think we'll go ahead and show a quick video. This is actually one of our video walkthroughs. We'll kind of talk about how, like, the role this plays and the offerings that we have. We'll go ahead and watch this, and then we'll let Lindsay talk about some of our decision making and how we arrived at this approach. Be warned, there is audio, so have your volume control ready. I'm not sure how loud this will be.
Started. Before beginning the simulation, you'll see a visual aid displaying the keyboard and mouse controls. Take a moment to familiarize yourself with these controls, as they will help you navigate and interact with the environment efficiently. Once you're ready, you can proceed to the next step. The user will see the screen through the viewport of a hazmat mask. To the bottom right of the screen, you will see an air gauge. Over the course of the 20 minutes, your air supply will decrease. If you do not complete the task of examining all objects within the environment before that time frame reaches 0, the simulation will end. In the sim, you will move around the site using the WSD control scheme detailed in the introductory menu. You can also move the camera using your computer's mouse. When a potential hazard is nearby and within view, focusing on it with the red reticle should cause it to glow yellow. Once it is glowing, you can press the E key to examine it. Rotate the object using the mouse control scheme detailed in the instructions. You can rotate the object left and right as well as toward and away from the camera. Additionally, using the middle mouse button, you can zoom in on the object. Note that some objects will have interactable labels. Click on them to view the labels more closely. Then click again to return to the normal view. Once you have sufficiently examined the object, you can use the buttons in the top right-hand corner of the screen labeled Mark Object as Examined and Return to Site to mark the object and return to site. Alternatively, to just exit the examination mode, you can click the button in the top right of the screen labeled Just Return to Site or press E. You can re-examine objects at any time until the simulation is completed. Once you have marked a potential hazard as examined, a hazard marker should appear above it. Open up the SIM's main menu to access an array of options. The hazard tracker is the first tool instructors can use to support the training process when students are struggling to identify all potential hazards within the site. When activated, it provides a visual indicator showing the number of hazards that have been found so far, allowing instructors to track progress and determine if further guidance is needed. The mute button allows you to quickly disable audio if needed. The Free Move feature offers additional support for instructors if students are struggling to locate hazards. When activated, it removes movement-related barriers, allowing instructors to freely move within the waste site and point out any missed hazards. The Reveal Hazards option highlights all hazards within the scene, providing another way for instructors to assist students in identifying potential dangers. The Hide Hazards feature removes the highlights previously activated by the Reveal Hazards feature. The main menu will also allow you to exit the particular module the sim is a part of, or alternatively exit the application altogether. You can exit the environment by traversing through the deck and line. This can be performed before or after locating all the objects that need to be examined in the scene. Note, if you exit the simulation before finding all the appropriate objects, you will have failed the simulation.
All right, I'll turn it over to you now, Lindsay.
All right, perfect. So as we built these augmented virtual reality simulations for the HAZWOPER training, the one thing we were trying to be very intentional about was keeping the instructor at the center of the learning experience, making sure that it wasn't a situation where the students could just click, 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 and be done with it, that the instructor has to lead through. It also gives the instructor the ability to control the pacing, the flow, and key decision points. Almost like one of those novels we read when we were kids. You turn to page 4 if you want this outcome, you turn to page 5 if you want this outcome, and guiding it through that way. So it allows the instructor to be as complex or as simple as they wish to be with the class that they're teaching. And you could do it differently every time. We can slow things down when needed, or if there's a critical moment happening that the students really aren't paying attention to, you can really dig down deep into that as well. That's especially important in safety training, where understanding the why a decision is made is just as important as the decision itself. So that's the whole reason we were going with that. This being a shared learning experience, it isn't an isolated headset only experience where you have one student getting to experience while the others are just watching them or potentially not even paying attention. It's designed to be shared, so we can project it up onto the screen and everyone can see what's happening as the instructor is leading them through. The instructor is doing what the students are asking and going through the motions of operating on a waste site based on what the students are asking for it to happen. It's a group activity this way, and it's a common scenario that everyone can react to as things happen as well. With the real-time discussion that comes with this type of application, the biggest advantage we saw was the ability, again, to just pause and ask, what are you going to do right now? Okay, that just happened. What can we do? The real-time discussion is where a lot of deeper learning happens, especially for our students, having the ability to let the mistake happen and then use it as a learning point, or stop it before it does happen, because if a mistake truly happened in training, it might be bad for everyone involved, depending on the type of mistake that was going to be made. So it's nice to be able to have that freedom with this type of a training tool. We've reduced cognitive overload for students that are new to hazardous materials as well. Like Kirk mentioned, trying to bring students up in the curve with people who potentially have been doing this for 10, 15 years is a big deal. So the environments can be simple or complex. They all look the same. It's not like you choose easy, medium, or hard at the very beginning. It's the same one, but with all those different toggle switches, allows the instructor to be able to make it easier on the student by turning on all the hazards, and then we can wander around and look at them, or leaving it all a secret and making them find things. Instructor-led delivery does help guide them so they're not overwhelmed. They stay focused on what's going on. It gives the opportunity to make that scalable lesson every time you use it, depending on the audience that you have. Excuse me. The reason we feel that this works best for HAZWOPER is the approach is ideal for introducing new content and practicing safety critical tasks. It also reduces time spent troubleshooting technology and keeps the focus on learning. I can personally say we had purchased virtual reality headsets to try to accomplish something like this in some of our classes, and they are collecting dust on a shelf because we purchased 5 headsets and never got one of them to work the way that it was supposed to be able to use it in the classroom. So having it set up this way is so much better for productivity, if nothing else. Ultimately, though, it aligns well with how we already teach. We use lecture, we use discussion and hands-on application. That's part of HAZWOPER or any hazmat type training. This being flexible and open-ended is an option that is utilized as much or as little as the instructor prefers. So what does this actually look like in a classroom, though? On the next slide, we'll show you how we're bringing these simulations to life. What you see here on this slide is how we translate the simulation into an interactive team-based classroom experience. With what we're planning to do and what we've kind of started with is we've split the students into separate groups. You have the ability to even put your students in separate classrooms and make them communicate, like you can see in the pictures, through radio communication. They're not able to, everyone at the same time, discuss. You have the one classroom, the one on the left, where they have the display looking at the waste site, and they're radioing information into the other classroom to make it a more real world application, because we're not always all able to be in the same area. Using the walkie-talkies, it is a hindrance because communicating over radio makes things more difficult, and you can use that to your advantage or take it out of the equation depending on the students that you have. But making it more, real world applicable is what we're really trying to do with this. It forces the students to communicate clearly with each other, deal with getting incomplete information, and operate just like they would if it was an actual incident. You will start to see leadership emerge, communication challenges, and decision-making under times of pressure. The setup, again, isn't just about technology. It's about practicing coordination, situational awareness, and teamwork. They're not just watching, they're doing. The scenario unfolds as they make decisions on what they're seeing. And through the different sims that we've built, the decisions they make in this sim directly correlate to the next sim and to the next one. What they find in the offsite drives what they're going to do in the on-site characterization, which drives how they set up their decontamination line and determines the PPE that they need. Students are actually able to fill out a health and safety plan, or a HASP, as they work through the SIMs, which is something that's critical with HAZWOPER operations. Being able to assign roles, you can set, hey, you're the incident commander, you're on the entry team, you're the safety officer, so they can kind of enter those mindsets, those roles, and experience different perspectives within the same scenario. You can also rotate them partway through. Hey, you're not the incident commander anymore, you are. That allows you to keep the ball rolling in the scenario, not have to completely reset, but give each student different jobs as they work through it. The engagement and realism does create a level of energy and engagement that's hard to get with other non-traditional methods. I like to think of this as like a really enhanced tabletop exercise. It's perfect for programs that don't have a lot of equipment or don't have the staffing to create waste site scenarios for every class that they're doing. Sometimes you just don't have the time. The employees come in and they need 4 of their 8 hours of training, or they come in for 2-hour nuggets, 4 times to get that 8-hour refresher. This is an opportunity to work through this. They're still getting the engagement, but not having to spend, the day and a half before setting up a site and the day and a half after trying to clean it up. We are currently working with 3 leaves on a professional video that will showcase exactly how this will look in a real classroom setting. That's going to give a much clearer picture of the interaction, communication, and overall experience as well. So we're looking forward to that coming up. But at the end of the day, the goal of this is just simple: to combine immersive technology with strong instruction and create meaningful job-ready skills for our students.
Yeah, thank you, Lindsay. I don't think anyone could have summarized it better than that. We've definitely gone to great lengths and had many discussions on how to provide instructors with not just a supplemental resource, but more tools at their disposal. So we've shown you kind of what that looks like, and you've got to hear about it. Now let's talk about what that actually means. So as Lindsay mentioned, this is not something that's built for VR headsets. This is built for desktop simulation on low-end hardware. We have currently done some testing, and these are built and meant for your basic lab computer. So whether it's a standard HP, we've even done some testing as low as Chromebooks. And so, if you can get something to run on a Chromebook, it's got to be efficient. They don't have a lot of power there. But again, we're lowering the barrier to accessibility. No expensive equipment, no free to use through both our site and through Kirk's network. And how we do that is through WebGL. So these are streamed live, so you do need an internet connection. And the reason that we've chosen that is simple. We have heard from many of our educators that one of the major barriers that they face is their IT department. So rather than making it a downloadable or executable file that has to involve IT getting it onto a computer, this only allows or forces you to access the Earth Center website. And so there should be no barrier there as far as accessing the simulations and the content. So we mentioned that there are some other offerings that coincide with our simulations. And so I'm going to walk you through where you can find them on our website and what some of those other resources look like. We already showed you what a walkthrough video consists of, but here you can see we've got a immersive ed center icon. Once you click on that, you'll be greeted with various cards that show the different topics that we have developed content for. In this case, you can see that we're going to go to the HAZWOPER card. Once on this page, the 17 modules that Kirk mentioned are listed out, and you'll notice that some of them have more than one card. For example, regulations overview only has the one, and so that's simply the course. We're going to show you in just a moment what some of the modified courses look like. But here under number 2, you can see that we've also included an instructor guide to coincide with the simulation. Because again, we want to make sure instructors feel comfortable using this. We know that if we give everyone the tools, there's a better chance that it'll actually get implemented and be useful in the classroom. So here is a look at what an instructor guide looks like. It goes through all the features that are available, a bit of the answer key and what to expect in a step-by-step format with illustrations. So again, this can be printed out as a PDF and something that you can have on the side. And the beautiful thing about this is rather than an instructor sitting up there trying to guide 5, 10, 20 students through this and having to stop for any technical issues or anybody that's stuck, because it's a guided experience, really only one person has to make sure they've mastered the simulation. And so from a productivity standpoint, that is huge. Here's a look at what some of the new courses look like. These are built in Articulate 360. And you can see that the modules are laid out on the side. And when you get into this, one of the beautiful things about this, there's a lot of nice things that can be done. So here are some of the interactables, whether it's just flipping around cards or something like in the lower left where it's actually like an AI-based scenario, kind of matching up some general assessment, and then kind of arrow keys or indicators that you can click on to gain more information about items in a scene. And so again, we hope that everyone will find this very useful. If you do go to use it and run into any questions, there are ways to contact us on the Earth Center website. We would love to hear from you, love to see how we can improve the experience. But now I'm going to turn it back over to Kirk to talk a little bit about how this can be accessed through their network as well.
Excuse me. Also want to just, kind of step back a little bit. The HAZWOPER program, the way this is designed is to meet the first 24 hours of a 40-hour program. 16 hours if you're going to complete the full program and be able to give some credit is hands-on. So this program gives the opportunity for the students that are going through this to experience and try things, make mistakes, so that when they get out and you have limited time with the equipment, 16 hours sounds like a lot of time, but it really isn't when you're setting up scenarios and running through. So having all the students on a somewhat level platform by going through this is great. We don't want them to make mistakes during the training, but more importantly, we don't want them to make mistakes when they get out into the field and actually are going to deploy for something like this. This is showing our website, and you can go to the website under programs and it'll list out with this is under, as I mentioned, the Community College Consortium for Health and Safety. We put on a 5.5-day greatest training annually to provide, and it is totally an instructor-based train the trainer. And we use this program as a prerequisite before they come in to the program. So that is one thing. We just finished up with a 2.5-day respiratory protection train the trainer program. We have an industrial-based waste program. Both of those have been offered at Barton Community College, where Lindsay is, and she's been integral as far as helping on that program. We do disaster response and training, train the trainer. That's done annually, where we bring folks in. And as I mentioned, we're governmentally funded. Again, all of our programs are heavily subsidized by our federal sponsors. And so that gives you the ability to come to our training programs with very little cost. Um, excuse me, I apologize again. Um, so I would encourage you, if you don't or are not have the experience in this area, to maybe take a look at our programs, sign up for them, and to get more opportunities. Also, it'll give you a snapshot of what kinds of equipment that you might need or want to have to develop a program of your own. So with that, I guess open up to any questions.
I actually just would like to make one quick, just to reiterate what I think Josh said in earlier, is that this simulation and all of the simulations found on the Earth website are free to use for instructors. There is no paywall. We want these to be used. We want to create as low a bar for use as possible for instructors. And so this is not a sales pitch to sell any of this material. This is just simply a presentation of the materials that we've developed and we would love for faculty to use with their students.
Yeah, that was my question. Sorry, this is Ed Kelly. Um, I got on just a few minutes late. I thought maybe I missed something. My question was the cost of the program, and you just mentioned that this is free to use for instructors to teach.
Correct. And frankly, it's free for industry partners, for industry to use as well. We want anyone who finds this valuable to be able to use it. This is an educational resource that we have been funded by the National Science Foundation to develop. And our mission is to deploy this information and get it utilized as much as possible to assist in students' technical education. There is no
Excellent. And
cost.
so we just go to the National Peat site, and we can find it on there for this HAZWOPER.
So the simulation itself is actually housed on the Earth Center website. That's where
okay.
all our simulations. So earthcntr.org.
Yep.
And yep, right there, earthcenter.org. And it's right there. And again, no paywall, no sign in. Feel free to peruse it and see what you think.
Very nice. And then you mentioned Kirk mentioned the disaster site cleanup. Is that
Yes, we annually put on a program. It's actually in Florida in January. It's a week-long disaster preparedness and recovery program, train the trainer program. And we partner with the Colorado Baptist Disaster Relief and put on a training program. And it's really designed so that you can train your students, but more importantly, respond in your locale or even outside your locale for disasters. It gives you the credentials to be able to go in and help out during a disaster. So that's also on our website, and you can go to the programs and section. It'll give you the details on that.
that's awesome. Thank you so much.
Yeah, our National Institute of Environmental Sciences is trying to get it widespread, both hazmat but also disaster relief in response to get people trained and knowledgeable so that they can assist during disasters as they're coming more and more frequent.
I was shocked that there wasn't more participants on the meeting today when I logged in.
Yeah.
So, yeah, excellent though. Great information. I appreciate you all.
Yeah, please spread the word, and thank you for joining us today.
Yeah, thank you, Ed.
Were there, I know previously, you guys had released apps and did pilots with them. Is there any way for just contributions to information on how they work or how students feel about them or anything like that?
Yeah, we taking kind of a small step back, we will actually be presenting this to a large group of instructors in the PEAT network at the end of April and collecting some feedback there. We may make some small changes, but yes, we would love to open it up to some classroom pilot testing to get some instructor feedback, to get some student feedback. Yeah, that's what helps drive these, helps us, make the necessary changes and make sure it's aligned with what's needed in the classroom. So absolutely.
Perfect. Thank you.
If
And
there's,
Lisa,
oh, go ahead, Josh.
Lisa, I know you were part of some of the early development of a different series of modules. We're working on getting some of those formatted over from what used to be augmented reality on mobile device over to the desktop WebGL as well. So if there are any of those that you enjoyed using in the classroom, we'll be making those available again here soon. We're just wrapping up some of the pump modules, and then we'll be going into some of the other sampling modules as well.
That's perfect. The sampling ones we've used, I think, almost every semester since.
Yep, those are next on our list. I imagine we'll be getting started here in the next couple months, kind of converting those over. It's not a simple process going from augmented reality over, but since we already have kind of the structure there, might even reach out to see if you want to be an SME and make sure those convert over, and if there's any updates that we need to make, and so on.
Oh, that would be great. I was going to ask how the difference between the Unity software and the new one, just with like user friendliness.
So they're both still everything's created using Unity. It's the deployment method that's changed. So instead of building them out for mobile devices, which was problematic because there were so many different devices and so much to account for, these are now just built as a desktop simulation. So we just need to make sure that they run on low-end hardware with no dedicated graphics card. We even go out and test these at like internet cafes with a weaker guest Wi-Fi signal just to make sure that, again, we're going to get good load times and a good experience in the classroom. So from a usability standpoint, accessibility is through the roof. Required support should be way down. Overall, it should just be a much more streamlined experience.
Sounds awesome.
And I would just say, like, throw it out to anyone who is on the call now, views this later. If you're interested in piloting, you can reach out to any one of us through the Earth Center, and we can link up and figure out what modules you're most interested in helping us pilot, what that'll look like. We have some stipends available for helping to test this as well. And if there's a different topic that you would love to see a module simulation put together for in the environmental tech space, something you teach or you've heard that would be really productive to have in a classroom setting, let us know. We are always looking for new projects, and we want to create resources that people need and will use.
With that, if there's no more questions, I just want to thank everyone for attending today. And if you are watching this as a recording, please feel free, if you have questions, to reach out to any of us via the contact information on the previous slide. Thank you very much for attending. We appreciate your time, and take care.